Triangle similarity. We have similar triangles when there is a correspondence between two triangles such that the corresponding angles are congruent and the lengths of corresponding sides are proportional. So this is just like last time when we talked about similar polygons, except we're specifically talking about triangles this time. So again, remember, side lengths, when you match up the corresponding ones, they all need to be proportional, meaning all the side lengths need to simplify into the same common ratio, and all the corresponding angles have to be congruent. Then we can say that a triangle is similar to another triangle. So we're going to talk about a few similarity postulates, and these are just like the congruence postulates that we discussed last unit. The first one is angle-angle similarity postulate. So this states that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So if we have these two angles congruent and these two angles congruent, that's enough information to say that the two triangles are similar. You don't have to know anything about the third pair of angles, but we've previously talked about the third angles theorem, which tells us that angle B and angle K are going to be congruent because, again, remember, the three angles of a triangle, regardless of the size, have to add up to 180. Here it says that the following triangles are similar by angle-angle, and we need to show that there are two pairs of congruent angles and give the similarity statement. So first we have angle B, which measures 48 degrees, is congruent to angle E, which measures 48 degrees. The other pair of angles that were given are not congruent to each other, but we're still able to find the third angle in each triangle. So let's go ahead and find the measure of angle C. So if we take 77 plus 48 and then plus x, this unknown angle C, they all need to add up to 180. So 77 plus 48, this is 125, plus x equals 180. And if you subtract 125 from both sides, we get x equals 55. So that means C is actually 55 degrees. Now we can mark that this angle C is congruent to angle F. So here are our two pairs of congruent angles. So the triangles are similar by AA, and then we can give our similarity statement. So again, the order matters. So if we say triangle ABC, so I want to go with the one that's 77, 48, 55. So that's going to be similar to triangle. We need to go DEF. In example number 2, there are a few extra markings that we can make. First, we have these intersecting lines, so we can mark vertical angles that are congruent. And then remember, whenever we see that extra set of arrows, that means parallel. And if you can find a Z, that means that we also have these alternate interior angles. So now we have two pairs of congruent angles, and they are similar by AA, so we can write our similarity statement. If I go triangle CAB, we went 1, 2, no markings, so that's going to be similar to triangle CED. Now on this last one, I want you to be careful because we have overlapping triangles, and we've talked about those before as well. So here we have a pair of congruent angles, and if you take a look at these two triangles, they actually share angle N. So there are our two congruent angles. So we have triangle, if I go LNP, that's going to be similar to triangle MNO. Our next similarity theorem is side, side, side. Now you have to make sure not to get this mixed up with our congruent triangles, even though we also had a side, side, side theorem for that one. For similarity, it is side, 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 but the corresponding sides have to be proportional. So this time we're not looking for the corresponding sides to be congruent, but they have to be proportional. So make sure you pay attention to these examples as we walk through them. So here it says that the following triangles are similar by side, side, side. Show that there are three pairs of proportional sides and give the similarity statement. So So we want to start off setting up our statement of proportionality. And I would say pick one triangle, and then across the top list the lengths from least to greatest. 3, 4, 5. And then you want to take your other triangle and also list those sides along the bottom from least to greatest. So we go 6, 8, 10. Now if you go least to greatest, that just makes sure that you're matching up the corresponding sides. Remember, because we're working with the numbers, you need to make sure that you match the corresponding sides appropriately. And now we want to reduce all of these. 3 over 6 is 1/2, 4 over 8 is 1/2, and 5 over 10 is 1/2. Since all of these sides are proportional, they all simplify to the same ratio. That means that these two triangles are similar by SSS. So we can write our similarity statement. So if I go D, E, F, so I was kind of going from the shortest to the middle side. Okay. Follow that same order from the shortest to the middle side. So we'll go triangle G, H, J. And then we take that same idea into example 2. Now, these are isosceles triangles, so remember, these sides are going to be the same, which means this is 9. These are going to be the same, which means it's 6. So really this one we just have to test the two different side lengths. So again, we can set up 6 on the top, 9, and then along the bottom, remember the smaller one first, and then the bigger one. And then let's go ahead and see if they reduce to the same. 6 over 4, they're both divisible by 2, so it reduces to 3 over 2. 9 and 6 are both divisible by 3, reduces to 3 over 2, and they are proportional. So we can write our similarity statement. Triangle, if I go A, B, C, and this is where you actually have two different options, and it's only because it's an isosceles triangle. We went A, B, C down the side of one of the legs and across the base. So you just need to make sure you go down the side of a leg and across the base. So you could have triangle X, Z, Y, or the other option I'm going to list here, you could have gone X, Y, Z. And again, it's only because this is isosceles and you have two sides that are the exact same length. When we come down to example 3, what you'll notice is that you have two equilateral triangles of different length. Now, all equilateral triangles are always similar for a couple of reasons. If we were just to make up a length and choose it, 4, these other sides would also be 4. And then if I just choose a length for this one, let's say 7, they would all be 7. And if you set up your statement of proportionality, the ratio will always be the same, 4 over 7, or 7 over 4. So just know that all equilateral triangles are similar. And again, for the equilateral triangle, because all the sides are the same length, for this one it's not going to matter what your order is when you write your similarity statement. So you could write this in any order that you want because all the side lengths are the same. So they all correspond to each other. The next one we want to talk about is side angle side similarity theorem. So again, we did have a side angle side congruence theorem, but make sure you know the difference. You have one pair of angles that's congruent, but remember with similarity, the sides have to be proportional. So again, that SAS does tell us we're dealing with this angle that's sandwiched in between the two side measurements we have, but again, sides are proportional, angles are congruent. So when we take a look at these examples, the following triangles are similar by SAS. Show that there are two pairs of proportional sides and one pair of congruent angles, and give the similarity statement. And again, remember, that SAS tells us it needs to be sandwiched. So here we have this pair of right angles, and then we are talking about the sides that are sandwiching that angle. Okay, so we have the right sides that we need. Now we just need to make sure that they're proportional. So again, we'll set up that statement of proportionality, and then we'll go small to large across the top, and then small to large across the bottom. And we need to make sure they're proportional. 6 over 3 is 2 over 1. 8 over 4 is 2 over 1. So since they're proportional, we'll write our statement. If I go FDM, that's going to be similar to, I went down the short side to the right angle and then across. So down the short side to the right angle and across. So I need to go triangle AVQ. In example 2, and this is where you need to be careful again, we have these two sides and those two sides, but we also have these intersecting lines, and that's where we get our angle. So we have side, angle, side, side, angle, side, and now we just need to make sure that the sides are proportional. So again, in the smaller triangle, we'll go 4, 6, and in the bigger triangle, remember, 6, 9. You always want to go in order from least to greatest. So then we'll reduce. This is 2 over 3. 6 over 9 reduces to 2 over 3. And they are the same, so they are proportional. So we have triangle TSU, similar to triangle. And again, I went down the short side to the marked angle and then across the longer side. So we have to go from V to S to R. Now in this last one, we don't have any numbers. So how do we check to see if the sides are proportional? First, again, remember, overlapping triangles have that common. But take a look at the markings here. So however long this is, it's going to be the same as ED, and likewise over on this side. So we're just going to take, I'm just going to put in numbers for an example. If DC, this marking with 2, if I make that 2, that means this would also be 2. So in the big triangle, that entire length of EC would be 4. Over here, with the marking of 1, if I mark that with 3, that means AB is also 3. So the whole side length of the big triangle AC would be 6. So I just put these numbers in just for pretend so that you can see that the length of DC, which is 2, doubles for EC on the bigger triangle. So that changes from 2 to 4. And then on the other side, BC, which is 3, doubles to AC, which is 6. And so these both reduce to 1/2. So even though we didn't have the numbers, those markings tell us that the length is actually going to double. So they are proportional. We have that angle, so we can write triangle. If I go ACE for the bigger one, that's going to be similar to triangle BCD on the smaller one. That's it for this set of notes. I'll see you in class for some more practice.